Okay, my dear students, now let us try to understand about ionization. So ionization is the process of making polar covalent compounds into ions. So that means they are not ionic in nature. In the previous case we saw the electrovalent compounds. Electrolytic dissociation is for electrovalent or ionic compounds. That is, we are just dissociating the compound into their constituent ions. That means they were ions previously, we are just breaking their bond, and we are converting the molecule into the cations and anions. But in the case of ionization, no such kind of ions are present previously. The formation of ions takes place in this process. So the process of making polar covalent compounds, and you already know that covalent compounds are not ionic in nature, they don't have ions. Okay, so they are covalent in nature, they are formed due to the sharing of electrons, not transfer of electrons. So unless and until electrons are transferred, you will not have ions. Okay, so polar in nature, why? Because of high electronegativity difference. So some polar covalent compounds are HCl, ammonia, water, okay, and things like examples like that. You have lots of examples which you studied in chapter 2. So this is not the place of making you understand that thing again, but let us move to our main motive, that is ionization is the process of making polar covalent compounds into ions. So let us take an example of HCl. HCl is a covalent compound, it is polar. Why covalent? You can see at the structure of HCl, it is formed due to the sharing of electron. One electron of hydrogen is being shared with the chlorine atom, and one electron of chlorine is being shared with the hydrogen atom. Okay, so this is how HCl molecule looks like, but it is polar in nature. Why polar in nature? Because hydrogen is electropositive in nature and chlorine is electronegative in nature. Hydrogen is having the tendency to lose electron, and chlorine is having the tendency to attract electron, and that is why what will happen, the shared pair of electron will hang most of the times, or will be towards chlorine atom, and it will be closer to a chlorine atom, and thereby giving a slight positive charge to the hydrogen atom and a slight negative charge to the chlorine atom. So this is what polar covalent compounds are represented like, or this is how polar covalent compounds are represented like. Okay, so what happens, my dear students, when we dissolve these polar covalent compounds in water, and you know that water is itself a polar covalent compound, so this ionization takes place in water. Okay, they will not get ionized in their original form. You have to add water, or you have to add these things into water. So water is also a polar covalent compound. Oxygen is having a slight negative charge, and the two hydrogen atoms are having slight positive charge. You know all these things, we taught these things, we studied these things in chapter 2. So what will happen when you will add the polar covalent compound into water? These two hydrogen which are having slightly positive charge, or which are slightly positive charge, will attract the chloride, will attract the slightly negatively charged chlorine of the polar covalent compound HCl, and this slightly negative charged oxygen atom will attract the hydrogen, the slightly positive charged hydrogen, and thereby breaking the covalent bond, and if the covalent bond is broken, this proton, that is H plus, it will become H plus, and it will move towards the water molecule. Okay, and it will make the water molecule hydronium ion. You know hydronium ion, we studied this in chapter 2. It will become hydronium ion. It will get one hydrogen atom more, and hence it will acquire a positive charge because of the excess proton H3O plus, and you will get the Cl minus broken due to the breaking of the covalent bond. You will get the Cl minus over here. Now you can see that you have a pair of ions, a cation, the hydronium ion, and the anion, the chloride ion, and due to the presence of these cations and anions in the solution, that is the polar covalent compound in water, it will allow electricity to pass. That is why polar covalent compounds are able to pass electricity, because of the presence of the hydronium ion and the anion. Now let us try to understand the difference between electrolytic dissociation and ionization. What is the difference between electrolytic dissociation and ionization? It's very simple. If you have understood the concept, you can write the answer by yourself. Electrolytic dissociation and ionization. is it takes place in ionic compounds only. Ionic compounds only. It takes place in uh, ionic compounds only. It takes place in polar covalent compounds. Okay, that is the very definition. Okay. Ions are already present. Already present. Just it's become just they become free. Just they become mobile. Okay, when you take the aqueous solution of the ionic compound or the molten state, you are just breaking the electrovalent yani electrostatic force of attraction, and ions are already present there. You are just breaking the ions, they are making the ions free. But in the case of polar covalent compounds, ions are formed. Ions are formed. For example, NaCl is broken into Na plus Cl minus, and for example HCl is broken into, when you add water to it, it is broken into H3O plus Cl minus. Hope you understood.